All right, guys, I'm going to do a few problems from your wave speed note problems. And the first thing that I want to go over with you is what is the equation for wave speed. So wavelength is what we use lambda, or this weird upside down y for, okay? And it's always used in meters. Think about it, wavelength, meters. Frequency is in something called hertz, and velocity is in meters per second. Same exact thing that we've been doing. So we know the equation that was given was wavelength is equal to the velocity over the frequency, okay? This is the exact same thing as saying wavelength is equal to velocity over frequency. I like to use this triangle a lot. We know that wavelength equals velocity over frequency, okay? So velocity over frequency is equal to wavelength. So velocity divided by wavelength equals frequency. Velocity divided by frequency is equal to wavelength. So let's real quick break this down. If I'm looking for the wavelength is going to be equal to V over F. If I'm looking for F, or the frequency, it's equal to velocity over lambda, or wavelength. If I'm looking for velocity, it is equal to lambda times frequency. Okay, so we're going to go through and solve some problems using those. You're going to have to just remember that frequency is in hertz, and we're not going to really be using hertz a lot in this science class, but in the future you will be. So for this first problem, let's go ahead and break it down. A certain FM radio station broadcasts the electromagnetic waves at a frequency of 81,000 hertz. So we know that F is equal to 81,000 hertz. These radio waves travel at a speed, or a velocity, of 3 million meters per second. What is the wavelength? So we're looking for lambda, okay? We know that lambda is equal to velocity over frequency. So lambda is equal to velocity over frequency. So all we need to do is take the velocity, so 3 million meters per second, divided by the frequency, which is 81,000 hertz. We just need to solve that, okay? So all we have to do is type this into our calculator. 3 divided by, and we get a wavelength of 37.037. So we're going to round that to 0.4. And remember, this is the wavelength. And when you think of length, and when you think of distance, and distance is measured in meters. All right, next one. A dog whistle is designed to produce a sound with a frequency beyond that which can be heard by humans. If the whistle produces a sound with a frequency, so again, we're given frequency is equal to 2,500,000 hertz. What is the sound of the wavelength? So we need to find the wavelength again. Assume that the speed, or the velocity, is equal to 331 meters per second. So we're looking for wavelength again. Again, we know that wavelength is equal to velocity over frequency. So all we need to do is plug this in. 331 meters per second divided by 2,500,000 hertz. I'm going to plug this into our calculator. 331 divided by 2,500,000. And you will get 1.32 times 10 to the negative fourth. It's a really small wavelength. How do we measure wavelength? In meters. All right, we're going to skip this one because it's asking for wavelength again. I would like for you to go ahead and flip over. And I want to solve for number 6 because it's asking you for the frequency. And I also want to do number 9 because it's asking you for the speed. So for number 6, cicadas produce a buzzing sound that has a wavelength in the air of 2.69 meters. So we've got lambda so far. 2.69 meters. If the speed of the sound in the air is 346 meters per second, what is the frequency? So we need to find out what frequency is. If you flip over and you look at this, frequency is equal to velocity over wavelength. So frequency is equal to velocity over wavelength. So we just need to plug this in. Velocity is 346 meters per second. Wavelength, or lambda, is 2.69 meters. We're going to plug this into our calculator. 346 divided by 2.69. You get a frequency of 128.62. Now for the units, frequency is measured in hertz. Okay? So you're just going to solve the problem, rearrange that equation. Okay? Last but not least, let's go ahead and do number 9. A wave with a frequency of 60.9 hertz. So we've got frequency equals 60.9 hertz. Travels through a vulcanized rubber with a wavelength of 0.90 meters. So we know the wavelength is 0.90 meters. What is the speed of the wave, or what is the velocity of the wave? So let's flip it over. We know that velocity is equal to wavelength times frequency. Velocity is equal to wavelength times frequency. So all you have to do is velocity is equal to 0.90 meters times the frequency, which is 60.9 hertz. Plug that into your calculator. 0.90 times 60.9. You will get 54.81, and speed is always measured in meters per second.